In my first video about basic electricity, you learned that current is basically the flow of electrons in a wire, and the term amps or amperes refers to how many electrons are flowing past a certain point per second. The super simplified explanation of voltage is that volts push current around an electric circuit. Voltage behaves like a pushing force, forcing electrons to start moving around, which creates an electric current. Okay, I want to show you an example. Over here I have an electric motor with some wires connected to it. This fancy thing is an adjustable power supply. It allows me to create nearly any voltage I want, which is useful for designing circuits, but you don't need one of these to start learning about electricity. You can just use batteries. The voltage I'm generating will be shown here, and the fun thing about this power supply is it can automatically measure how much current is flowing, and that's going to be shown here. I want you to see how when you increase the voltage going to the motor, more current flows. If we start out with the power supply set to 0 volts, the motor doesn't do anything. Now let's set the power supply to produce 1 volt. Immediately you can see that there's current flowing, roughly 1.8 amps. And when there's current flowing, energy can flow from the power supply to the motor. Now let's increase the voltage to 2 volts. Now that we have a bigger pushing force, more current is flowing, 2 amps. So more energy is flowing through the motor, so obviously it's going to turn faster. And the more I crank up the voltage, we get even more current and the motor speeds up. Okay, that's just one example of what voltage does. You can use a voltage source to power motors, light bulbs, electronics, and other things. Another important example of what voltage can do is carry useful information. You can use different voltages as electrical signals that represent data. In this example, 0 volts or 5 volts represents binary zeros and ones in a communication system. Now, this is way more advanced than what I want to talk about in this video. I just want you to understand that sometimes voltage is used to power things that draw high amounts of current, but you can also use voltage as a signal, and almost no current flows at all. You just create the changing voltages with a transmitter and detect the changing voltages with a suitable receiver. Now, remember, the whole volts push amps thing is just a helpful simplification. What's really going on here is that there's a chemical reaction inside this battery that's creating a voltage. This side of the battery is more negatively charged than the top of the battery. Negative charges repel negative charges, so this side of the battery will push electrons away from it. Electrons push other electrons, current flows, and the electrons on the top side get attracted to the positive side of the battery, and everything flows in a complete circuit.